Hey everyone, this is Scott at Celigo, and the ultimate goal of this video is going to be building a custom connector using Java that runs in your own AWS account. And you would build a custom connector when you want to use your Integrator IO account to connect to something where we don't have a native connector for that application. So there are probably lots of old custom systems where you will not find a native connector, and you need to build something custom yourself, and this is always your way out of being blocked by lack of connectivity. Almost every iPaaS product out there will have some sort of connector SDK, and I'm just going to give you a preview of ours. Okay, before I jump into the specifics of building this custom connector using Java, I want to take a step back to talk about the framework that we have for extending the functionality of Integrator IO. So we have a framework called Integrator IO Extension Framework. And this framework has actually been around for a long time. It was one of the very first features that we launched when we launched our product, at least 5-6 years old. And the reason this framework was created at the very beginning is because, again, the core nature of an iPaaS is it has to be able to connect to anything that you want to connect with. And so in the early days, this framework was actually very popular, heavily used, and it has quite a lot of functionality. Now, though, 5 years later, the use for it has shrunk drastically. So we don't see the need for this pop up as much. And there's a lot of functionality in the framework that you will probably never need. But nonetheless, building custom connectors is still something that comes up that you may need to do from time to time. Again, for older systems that use strange protocols, older protocols, things that we just haven't seen and exposed in the product natively. And so I want to do a video that shows people, what is this framework? How do I use it? And, a reminder probably to many people that we have this and it's still around and fully supported and so on. Okay, so what we're looking at right now is Celigo's public GitHub page, and in here is a repository called Integrator Extension. And this is probably the best place to start when you're going down the path of, hey, I need to build a custom connector. So go to this repository, Integrator Extension, and then just look at the README. Now, this specific implementation here is in Node.js. So if you are familiar with Node.js, and that's what we built a lot of the early product with is Node.js. If you are familiar with Node.js and comfortable, then I highly recommend using this exact module to build your custom connector. It's basically all the scaffolding that you'll need to deploy something really quickly. And then all you're going to implement are the specific functions that are related to the thing that you're trying to build. And then there are two options here. If you want to do it with Express and run it as a server on your own AWS instances, or if you want to run it in Lambda. So again, if you're using Node.js, I would just use this module that we have here as is. It's going to save you a lot of time. If you're not using Node.js, I still recommend coming over here and reading about the framework from this lens, and just kind of ignore the Node.js specifics and pay attention to all of the functions and interfaces that are available to you. And specifically, you're going to see, so like when we get into building a custom connector, we're going to go down into this bottom section here. There's 3 functions that you need to implement: ping, export, and import. And we'll get into this in more detail soon. But what you're going to be able to see are what are the arguments that Integrator IO is going to send me? What are the things, the data, the properties that they're going to send to my code, whether your code is Java, Ruby, Python, doesn't matter. You can see here's what they're going to send me, here's what each property means, and here's what I need to return back. So this open source repository in Node will still give you a lot of information on what you need to implement in any language as it relates to the interfaces of the functions, and again, what you're going to get sent to you and what you need to return back. The reason why we never did a kind of a module for every language is just because in the early days we were all using Node. A lot of our customers that were doing this and partners were fine with Node, so we did this open source in Node.js. But again, there's nothing stopping you from doing it in any other language. You just have to do more of the scaffolding yourself. And then in this video, we're going to do Java to show like it's actually not that hard to do this, especially in this day and age, with things like ChatGPT to help us along the way. So again, if you're building a custom connector, you can use any language, and then I highly recommend coming over to our Integrator Extension open source module that we did for Node, where you can just see all the function interfaces and all the details. This is like the best source of documentation. Okay, so all right, so now let's get into the specifics of what we're going to build here. And like I said, we're going to build a custom connector using Java. And the thing that we're going to specifically connect to is SQS. So we're going to connect to Amazon SQS queues. And we're going to do this using JMS. So the cool thing about using JMS is that you will, it should then be very obvious how to then do a different queuing system. Let's say you don't use you don't use SQS, but you use ActiveMQ or RabbitMQ. JMS has plugins for all of those things, and so it's very easy to see. Okay, well, I saw how he did an for SQS. I'm just going to do something for RabbitMQ. Piece of cake. Okay, and then the only reason I'm choosing SQS is because I don't have a queuing system. I didn't want to launch a whole queuing system and deploy that to test. But testing with SQS was easy because we have AWS here at Celigo and so on. So, okay, so we're going to do a JMS connector specifically to connect to SQS using Java. The first thing that you're going to do in your Integrator IO account is create what we call a stack. So you're going to go over to your resources on the left nav, and in there is this thing called stacks, and we're going to create a stack. You name the stack. What is its purpose is how I organize these things. So I just called this JMS connector. You can choose what type you want it to be. So we have two different types that we support, either on Lambda or server. This example, we're going to use Lambda because that is by far the easiest. So I'm going to say, hey, I'm going to use Lambda as my backend stack. I'm going to tell Integrator IO how to authenticate to your Lambda function. And then it's going to send stuff to your Lambda function from our product to run in your flows. If you were doing a server, you would have to set up So what happened, the difference between Lambda and server is where you just have a web server, a lightweight web server, and it will get sent API requests that contain the same data in a REST API type payload. The Node.js Express implementation, that's something you could quickly deploy on AWS. That's the server implementation, and you would see that it's basically just an API server, super lightweight, and then all the same properties coming through. And that scaffolding I talked about, it's just handling the high level. Here's the request, here's the function, and then all you have to do is implement the function and not deal with all the request handling. Okay, so I choose AWS Lambda, and then again, it's going to ask you, what's your access key, what's your secret key? These are things you would set up in AWS itself. If I go back over to the open source GitHub repository, you'll see that there is actually a link to AWS Lambda for the Node.js version of this, and it kind of gives you some. If you're not familiar with launching Lambda functions on AWS, it actually has a little checklist of here's how you set up the AWS account, the IAM policies, and just walks you through that. Sometimes that's tedious. I don't think it's that hard now because you can actually go to ChatGPT also and ask for instructions. But we do have instructions here. And then again, when I built this, I used ChatGPT. I just said, hey, I need to create a Lambda function. I haven't done this in a long time. Can you please walk me through the process? And ChatGPT was also really great at giving me guidance. And I'll show you my chat soon here. So you get your key and your secret key, plug those in. You say what region at AWS you're running this. Tell us the name of your Lambda function, and we'll look at that in a second. So I just called it JMS connector, and then the language that you want to use. Now, important note on this language. Okay, so back in the early days, they supported Node.js. That was like the very first thing that Lambda supported was Node.js. And so we built support for Node.js, and then they supported other languages like C#, Java, Python. It actually doesn't matter what language you pick because Java, all the other languages behave the same. Node.js behaves a little different. So if you're using Node, set Node. If you're not using Node, it actually doesn't matter what language field you set. The interface is still going to be the same. And we may get rid of this field. It's not that helpful. But anyway, just set your programming language. If it's Node, set Node. If it's any other language, it doesn't matter what you have in this field here. Okay, so I create my stack, and then on the AWS side, so I'm going to jump over to my AWS account real quick. So again, you just go to services, Lambda, functions, create a new function, give it a name. This is all real basic stuff. They set up a lot of the stuff for you when you walk through their wizard. And then once you have the JMS connector Lambda function created, you can then upload code from code source, from a zip or a jar file that you build locally. So hopefully this part is obvious for anyone out there. Just create a Lambda function, give it a name that matches what you had in Integrator IO, the stack. So it's easy to correlate the two, and then you're just going to upload code from your computer that you develop on your local computer. Okay, so now the first thing that we're going to do once we've created the stack and created the function is we're going to implement the very first function needed for Integrator IO to talk to your Lambda function. And that function is called the ping connection function. And let me first show what it looks like on the Integrator IO side, and then we'll jump over to Eclipse to look at what it looks like in Java, and then hopefully it'll be obvious how those two things link together. So I'm going to go over to Resources, Connections, and I'm going to go to the connection that I created for this wrapper, this JMS connector, this JMS Lambda stack connection. Okay, and the type of so when you choose the application, this is not going to be intuitive probably. So you just got to remember this. When you're creating the connection, you're going to create an application you're going to create a connection where the application is type wrapper. The word wrapper just means that it's a word we chose a long time ago. It means that you in your function are wrapping the functionality of some API, some custom thing. And so you're interfacing with your wrapper of that thing. And so just again, remember, pick application type wrapper. And then once you choose wrapper, you're going to see these fields pop up. It's going to say, okay, cool. You're going to be dealing with a stack. We know it's a stack. And what's the function that you want us to call to know if this connection is working? So I call it ping connection. You can call it apple, banana, it doesn't matter. But I say, hey, I have a function called ping connection that I want this connection to call. And then it's going to be my responsibility in Java now to build the function ping connection. And then that function's responsibility. So it'll be sent all the details of the connection. And let me quickly go back to our open source documentation here to give you a sense of what the ping function looks like. So it's going to be sent a bearer token, the connection resource itself, and then also any imports or exports associated with the connection. And it needs to return back an error. If there was a fatal error, it can return an error, or a response object that tells you if the ping was successful or not. So this is basically a canonical format that you have to return, where you say, hey, it works or it doesn't work. And this documentation here will give you the details of what you need to return. Okay, so I say what my function is. I'm going to go implement that function, and in that function, I'm going to obviously then use the things that were sent to me to ping the thing I'm trying to connect with. And if that ping works, like if I feel like the call that I decide to make as the ping logic works, then I send back a code that says, hey, it's successful. Otherwise, I'll return with an error saying it didn't work. And then when it doesn't work, then Integrator will say, okay, well, this connection is offline, and it'll mark as offline. And all the functionality you get with Integrator IO and offline connections will then take effect. In the advanced section, maybe the most important thing to take note of is the concurrency level. So this is where you can control the number of parallel requests that will get sent to your function at the same time. So if you're dealing with a system that can't handle a lot of parallel requests, you're going to set this to a lower value. If you're dealing with like a database that can handle just infinite amount of reads, then this can be as big as you want. So I have it set at a really high value, 25. That means that at any time there could be 25 requests getting sent to my function at the same time. Each request, remember in our product, each request could be a batch of 1,000 records. So it's quite a lot of data when you set the concurrency. It could be quite a lot of data when you set the concurrency level this high. All right, and then down below are two very important fields also. So we have an unencrypted JSON field and an encrypted JSON field. Okay, so these are your most important kind of buckets to put in the data fields that you need to connect to the thing that you're trying to connect with. So again, it's real general purpose. You can send it whatever you want, and you have encrypted and unencrypted, because for unencrypted, you can send like username. You could send URL. You could send anything that is not like security sensitive. And then, of course, you're going to always have some sort of security sensitive field too, like password, or in this case, AWS secret key. And this is not the same secret key that I have on the stack level between Integrator IO and my AWS function. This is like a different IAM user that I have for SQS itself. So this is you got to separate the two things. There's the stack itself, which has its own authentication, where it's our product talking to your code infrastructure, and then within that, you still have, we're connecting to different systems and different apps from within the context of this wrapper. And here's your place to send, like again, username and password. And so, and then you'll notice that the encrypted field is empty. That's a security design that we have. Anytime that you save a connection record in Integrator IO, you always have to re-enter the encrypted values from scratch. And that is a protection that we put in place so that only someone who knows the secret values can change the non-secret values. If we didn't do that, then someone could come in, and change like a URL to go to some malicious server that then sends the secret key that's in our database, and we don't want to ever allow that. So always, if you want to change anything in a connection record, you have to always update the encrypted values, submit the encrypted values again to prove that you are the owner of this thing and not a hacker. So it's annoying. I get frustrated when I have to redo this if I want to change like concurrency level. But it's an important security precaution that we put in place. And a lot of the times you set up the connection once, you don't ever have to set it up again. So you do it, it's done, and you're rarely updating this. But if you do need to resubmit your encrypted values. Like I would have to retype in my AWS secret key with the value to save this connection again. Okay, so that is the Integrator IO side of this. I create a connection. The type is wrapper. I say what function I want to call to ping this connection to know if it's working, point to the stack that I created already, set the concurrency, set the unencrypted, encrypted values, save. This is done. Now, Okay, so now we're going to go over and look at the Java code that implements the ping function, and we'll also take a look at just the larger scaffolding for the Lambda function itself. So I'm going to go over to Eclipse right now. And so this is the entirety of my Lambda function. It is just one Java file, 240 lines, so not that big. And so, you know, the top level function, so you're going to kind of create all this stuff regardless of what you're doing. Sorry, the Lambda request handler implements request handler with this function, this method, you know, handle request with a map. So this is the right input, the context with the right output. And again, this is all standard AWS stuff here. I'm going to open source. I'll actually upload this code to our open source repository, so you can go look at this as a starting point if you're doing one of these. So I'll upload this, but you can also ask ChatGPT, like, hey, you know, I'm building my first Lambda function. Here's the input and output that I'm expecting. Can you just give me the scaffolding? It also will give you this as well. So either or, use ChatGPT, or just start with, I'll upload this exact code, and you can just copy and paste this, and then, you know, scrap it and rebuild whatever you want to build. Okay, so you get your top level scaffolding in place for Lambda, and then you know, I notice I'm doing a lot of logger stuff, so I can see the ins and outs of what's coming in and what I'm returning for debugging. If you want to then see, so on the AWS side, if I go back over here, where is it here? We can monitor the function, and you can view the CloudWatch logs to see anything that you log. So that's really handy. You just put in a bunch of loggers, then view the logs, and you can see exactly what's coming into your function. And you'll do that often when you're building stuff, because you'll want to know what got sent, what's the format. It's helpful to view these logs for sure. Okay, so now in here, so I do some validations at the top. I just want to make sure that I'm dealing with a wrapper. I'm not going to go into too much detail on the error handling, but I'm just doing some validations and make sure that I'm getting the right thing from Integrator IO. Otherwise, I'm just returning with an error. Let's say that I do get the right thing. Then I'm getting my credentials from the connection. So I want to make sure that regardless of what I'm trying to do in this code, that I always am sent the AWS credentials for the thing I'm connecting to. So here it's confusing in the sense that we're in AWS building a stack with Lambda, and then also connecting to an AWS service. If it was some other service, this could be like the RabbitMQ credentials, you know, so it's whatever credentials you're trying to connect to is what you're gonna get. And so I'm just doing this top level extraction at the top, and if I can't get the credentials out of the connection resource, I'm returning an error. All right, so now I get into, okay, well, what's the function this function, what am I trying to invoke now within the context of Lambda? And you'll see here now, this is the ping connection, this is consume message, send messages. I'll go into these ones in a little bit. But back to the ping connection, this is where I've implemented that. So if the function that gets sent to me is called ping connection, which again is what I defined over on the connection itself, ping connection. So this is going to get sent to me in Java as the function. And then I'm just going to implement a ping connection function. And you'll see here it's a very simple function to implement. All I do in this case for SQS is I'm using AWS's SDK. I create an object to connect to it, and then I call the list queues. So if I can list the queues with the credentials given to me, then I know that it worked. And so I return a 200 status code, which is the code that you need to return per our documentation. It's the interface that we have. You need to return a 200 status code, and that says to Integrator, oh, this connection is working. Otherwise, create an error response with a 401 code. We use 401 code to say this connection is not working. Ping connection did not work. So on the Integrator IO side, when it pings your SQS queue, it's basically sending a request to your Lambda function with that first level of authentication between Integrator IO and your Lambda using the IAM role set up there. And then within your code, you were sent credentials to the thing you're trying to connect to, which in this case is SQS. And we're just doing a list queues call. And if it works, we say, hey, we send back to Integrator.io a 200 code. And then Integrator.io will say, cool, this connection's working, let it save, mark it as online. Otherwise, we return back a 401 code, and Integrator.io will then interpret that as this connection is not working. You would see an error when you save this saying, hey, connection's not working, here's the error that we get back, and the connection would be marked offline. All right, so that's pretty much it for pinging connection, the function, the creating the connection. And so now once this is done, you kind of have, and again, you do need to upload your, once you build that code, you would then, do a build I use Maven install, build it, and then upload the jar using the code tab on your AWS Lambda web console, and then so now it's live. So now you have kind of a working connection to this system where your code is handling the request to talk to that thing you're trying to connect with, and you have your first piece working. So this is always a good milestone, is getting once you have this scaffolding in place, you're through all the hard parts. It's all the little tedious setting up these configs that are often the most time-consuming things. So again, this is a big milestone to get this part working. Your connection is there, and your stack is running, and you see the code getting executed. You're spitting out logs. You've got your validations at the top. Win-win-win here. Okay, so now that we have that working, we don't want to stop there. We want to build. The reason we're building this is because we want to build flows to this system, that we didn't have a connector for. And so let's go now over to our homepage in Integrator.io, and I created. So this is just a playground account that I have, and I created an integration tile called JMS connector testing, and I just have one flow. Again, I just named it JMS connector testing, and so this flow is very simple for the purpose of this video. We are going to consume messages from a queue, and then we're going to send messages to a queue. I haven't even implemented the send part. I'm going to leave that out because I think showing you how to set up this connection and then also getting the consume part working is enough so that the sending messages, it should be really obvious how to complete the story if you ever wanted to. I don't know that anyone will use this specific code that I built. It's mostly just there for an example. So again, I didn't implement this, and we're not going to go into this one. We're going to just show how to do the export, consuming part, and then the rest should be obvious. Okay, so again, create your flow. Now I'm going to create a new source. So in this flow, let's just say I want to consume messages from a queue. So this is a very popular thing to do, especially in a flow. You want to consume messages from places. That's the nature of an iPaaS, is consuming data from different apps, and then in some cases it's actually going to be some queue system that you have running. Okay, so I created an export. Again, you choose the type as wrapper. So the first thing when you create an export is going to ask you what's the application. Remember, choose wrapper. And again, that's just the terminology that we at Celigo chose back in the day to say, hey, this export is wrapping some system that I built, and so on. So, okay, so I build the export, I name it, always give it a name of that represents what it's going to do. In this case, it's just very generic. Choose your connection. And then here's, these two fields are really all you got to understand. It's just, okay, when you export, you're going to invoke a function that you build. So I just said, okay, I'm going to call this function consume messages. And then, of course, in Java, I'm going to implement that function. And then because this is an export, it's going to be sent certain fields and information that, give you all the information that you need to run the export to consume the messages and so on. And if you were to go look at our open source repo for Node.js, you can see, here's the export function, and it just tells you here are all the fields that we're going to send you to then run the export. And maybe the most important things obviously are the connections. So we're going to send you the connection as well, so that you have the credentials to then invoke that system. So you're always going to be sent the connection and the credentials anytime we invoke your function to do anything. And then I think another important thing is this type field. So we're going to tell you if the user set it up as an all, meaning like export everything out of the system, or maybe it's a delta, meaning like, hey, we only want you to export data from this time period. So Integrator O, when it's a delta, it's keeping track of the export window for you, but then it's your job to then use this timestamp that's sent to you. So when you get a delta, you'll actually be given timestamp fields like, hey, the last time it ran was here, here's the current time. And so you're going to use that window that it sends you to implement the time, to add those time fields into your query. Or, in a queue system, it doesn't make sense. But if you were doing like a database or some other system that had time fields that you could use in the query, you could use this delta functionality. So again, that's something where you can implement that functionality if you need it. And then in our UI, you would say like, hey, I want to do a delta, an all, a once, a limit, and so on. It's just you have to then implement that logic in your function. And then finally, you have this configuration field that you get to set. So here is where you could build something really generic in your Lambda function. Like you could build a Lambda function to connect to 20 different systems if you wanted. And then use these configuration fields to just point to what it is you want to run in your Java code. So in this case, I'm just saying, hey, I want the user who's going to use this connector to be able to send the queue name. So I just implemented the logic to where it expects a queue name. So if you say consume messages, you have to tell me what queue name you want to consume from. If I was only going to ever consume from one queue and I didn't want to make this a configuration option, I could also do that as well and just hard code this in my Java code. But again, you can make these as generic and abstract as you want. And then this configuration field is where you would then use the UI of Integrator IO to send the config properties to invoke the specific things that you want to invoke. So like, dev teams, IT teams, this will be very intuitive, like how you can use this to build really, really versatile stuff. You implement connectivity to something once with a lot of config options that your teams can then go to town with some really lightweight documentation on what are the properties and what's available and so on. So again, creating the export that goes and gets data out of the SQS system, it's just a matter of pointing to your wrapper, saying the function that you want to call, and then defining the configuration that you want to send, where all these things are fluid in that you, the developer building the wrapper, get to define them as well. Okay, so now let's go look at the Java code to implement consume messages. So this is also really quick. So again, back to my top level function, everything comes in the top to the handle request. I do the validation, I get the credentials out of everything, and then now I'm in which function is it? It's consume messages. So I did a little logic here to validate some stuff. Not going to go into that in detail. And then I built a consume messages method that we'll look at here. And here it's just, again, using AWS, SQS, JMS, open source stuff to establish a session, a queue, a consumer, and then I just go into a loop, while the size of what I've retrieved so far is less than the maximum response size allowed. So like Integrator, okay, maybe I should have discussed this. Integrator is going to tell you the maximum response size that it will allow you to send back in one single request response loop. So you can't ping your Lambda function and then get back gigabytes of data in one single call. So it's going to give you a property called max response size that you have to work within. And then so I'm just doing a loop where I just consume a message, I see how big it is, and then I add it to a running counter. And as long as I'm below my max response size, I keep looping until I've consumed either all the messages in the queue or I reach that max response size. Once I get to either of those, I stop and I send back all the data. And then I also have some logic, like if it's a text message, if it's a map message, if it's an object message, then I'm just transforming those things into the format that I want them to be. Like if it's a text message, I will try to parse it and see if it's JSON. If it's not, then I just create a new kind of simple object where the text message is the field name. So you are always going to be returning back JSON, but it lets you control like what that JSON is going to look like. And sometimes the messages in SQS will be JSON themselves. So I'm just doing a parse, and if that works, then I send that back as is. So I made it kind of generic there. And then once I'm done, I just close the consumer, close the session, close the connection, log some stuff, and then I return back, the structure that Integrator IO wants, which is a data property with an array of JSON objects representing the data that came out of the queue that I built up above in that while loop. And then I also say like, hey, is this the last page? So basically, every time that we invoke you on your side to get data, we need you to tell us, hey, are you done? Because let's say that there were 1 million messages in the queue and we got to 10,000 of them and we hit our 5 MB limit that was there, or 10 MB, I forget what the limits are, 20 MB. Let's say we hit that limit and so you stop. You don't want to stop. Like, you still want to consume the whole 1 million messages of the queue. So you're just going to return back last page false, and then Integrator IO is going to say, okay, cool, I got the first 10,000 messages. Pass those along in the flow. So if I go back to the flow itself, so it over here is saying, okay, got the first 10,000, pass them onto the flow to the next step, but it's going to keep going, and it's going to call back to you again. And it's going to, and then your code is going to say, okay, get the next 10,000 and the next 10,000, and you'll keep going until you say that you're done. And when you're done, you'll just return last page is true, the Boolean value true. And you can also pass state as well. So this is not in a queuing system. I don't need this because I'm just consuming and I don't need to like keep track of cursors or anything like that. But there is the ability to pass back state, in which case the state will get sent back to you. So if you're dealing with like a database, a cursor, an API, where there's paging configs, you can pass that stuff back and forth as well. It's all supported. Okay, so that's it though. So that's the export. That's the Java code. And again, so then you run this, it'll spit out the data. In my case, I just posted a couple messages to a queue to see it come out. And then it goes to the import. In my case, it's failing because I didn't implement that part. If we go look at my send messages, it just says not supported yet, not implemented. And again, I'm not going to, hopefully from what you've seen so far, it's pretty obvious what you would do. You would just do something very similar where you're sending messages to a queue based on what Integrator IO sends you. The payload that we send you is defined here in the documentation. Most important thing is just the data that you get. You'll get pre-map data, post-map data. We send you both. So in Integrator IO itself, you can map. You map objects from one form to another. And then in this import, we'll give you the post-map data. So this is what the data looks like after mapping has taken place. But if you want to access something on the data before it was mapped, you can. We just give you both of those payloads to work with. Most people will just work with the post-map data. But again, you can define your mappings to change things and so on. So all the functionality of Integrator IO is here available to you: filters, transforms, mappings, and then you get those payloads, the results of those payloads in your Java code to then do what you want. Okay, so now. Okay, so I talked a lot about ChatGPT, and let me just quickly show that as well, like just my journey. I haven't programmed in Java in a long time. Haven't built a Lambda function in a very long time, and so this day and age, it's really cool how AI can help accelerate your journey. So I just went over to ChatGPT 4.0. I said, hey, I built my very first Hello World AWS Lambda function. In which case, I actually asked a different ChatGPT for a Hello World function. I didn't even know how to do that much. I needed help. So I did that, and then this is kind of like my second pass. I gave it my initial code and just said what I'm trying to do. and you can actually take my code that I'm going to post on GitHub, and just say, hey, here's a Lambda function that does this SQS stuff. But I actually want a Lambda function that connects to this database system. And you'd be surprised. It'll wipe out all the SQS stuff and put in your database stuff and give you a really good starting point. And so then it walked me through like Maven and how to do this in Eclipse. And it's a long chat because I was just trying a lot of stuff. But again, the point being is just anytime I wanted to do a change, instead of like building it from scratch from my brain, like I would have 5-10 years ago, now you just kind of tell ChatGPT what you're trying to accomplish in your code. Like, oh, they're actually sending me this configuration field, and it contains these values. Can you add some validations that they always send me this value in every call? It'll go and modify your code and do that for you. So it's just a really great helper. And especially if you haven't coded in a while or you don't code often, this really it gives you like a little programming expert to help you bring this stuff live really quickly. Okay, so I think that's everything I wanted to cover. So I'll post this video with links in the description to all the pieces that I shared, like the GitHub repos, and then again, just taking a step back, recapping on what we just saw. Integrator IO. So we have 410 connectors available right now, native ones. And some of these connectors are universal ones. So like anything HTTP, you don't need a wrapper. You don't need to do this custom connector stuff with a wrapper and a stack. Like you just choose our HTTP universal connector. It has all the functionality of every auth, every paging mechanism you can think of. So you don't need to do this, and so there's a lot of connectors now that we have, and you rarely need to do this stuff, but nonetheless there are still times where you need to connect to something that is not here. And if you're an IT leader, or in my case a CTO, you pick these platforms for your teams to use. You never want the feeling of like, I'm going to get blocked. I'm not going to be able to connect to the thing that I need to connect to. You always need that way out. Well, this is your way out always with Integrator IO. If you need to connect to something where we don't have a connector, you use this wrapper option, and you go and build the connectivity to the thing in whatever programming language you want. Again, Node.js is going to be the easiest because we have a lot more open source scaffolding and collateral ready to go. But as you saw here, you could use Java or any language. Like if you're doing Lambda, which I like a lot because you don't have to host anything yourself. They have Ruby, Python, C#, Java, Node, lots of options. And then if you're doing your own server, then it's anything you want, as long as you want to host the server, and then you just implement the right API interfaces. So again, as an IT leader, CTO, dev leader, picking a platform, if you're ever worried that the connectivity is not there, this is, at least for us, our answer to that. You'll never be blocked. You always have this as your backup, but most of the time you're just going to use a native connector. All right, everyone. Thank you so much for listening, and hope you found this useful. Bye.